Maybe we can start from an intro of everyone here at Seed and also what project you're working on, what specific problems you are solving.
Hello, everyone. My name is Vladimir. I'm co-founder of Algebra, and we are doing the best decentralized exchanges during the last 4 years. So we try to fix all the problems with the decentralized trading, like impermanent loss, like high slippage, and so on. So that's our everyday activity.
My name is Xiang from Primus Labs. So we at Primus Labs actually building like zkTLS protocols to bring like off-chain data, especially like private data, to be authenticated, and then they can be utilized on chain, especially like when we combine with like zk technologies like zkVM or other stuffs, that we can rebuild everything that existing in Web2. I especially focus on the private data, and then we can move them to on-chain in the Web3 case by leveraging blockchain, the benefits of that.
Hi everyone, happy to be here. I'm Sylve, I'm the co-founder and CEO of Hyli. We're building a full-on layer 1 blockchain that is optimized for ZK-based application. The objective is to make it as easy as possible for any developer to use any of the good tools that is available in terms of server-side proving, client-side proving. So Hyli does two things really well. We have very fast consensus, a scalable DA layer, and native proof verification.
Hello, my name is Milica. I'm developer relations engineer at zkVerify, and I'm here to represent zkVerify. What we do is we verify zero-knowledge proofs across multiple chains and with different proof types.
The next question is basically more tapping into why you're building in the ZK space. And I know, Vladimir, Algebra is not exactly a ZK project, but actually taps into ZK technology to for its benefits. Can you maybe share a little about why you decide to work with ZK and what kind of like reasons behind the technical choices or strategic choices?
Thanks for the question. So for this, I need to dive a little bit into the decentralized exchanges problems. So we know it's if you go to like Uniswap, SushiSwap, PancakeSwap, during the last years, it was the same protocols for all the pairs, for all the chains, and it's wrong because every chain is different, a pair is different, and maybe it's like become volatile on Binance, and we should react somehow. So we came to conclusions that we need to see what's happening on the market and react in a DEX to get max benefit for the users. And the question how to do it. So we try to do it on chain, but it's execution huge gas costs, and sometimes we don't even require a block to make our calculations to understand what's happening. And that's how we came to ZK. So it is only the way to us to get on-chain trusted information, which we can use for our decisions. It's not why we decide to go to ZK because of marketing, but there's no other way how we can understand what's going on, process the data, and then use it inside of our protocol. So that's why we're in ZK.
Xiang, do you want to share like why you are building ZK?
Yeah, so the motivation of our focus is that we found that for now there's very limited data on chain. You only have like transaction data there, which I think is not necessary to build a very complicated applications, like especially related to finance. So there's kind of problem is that can we bring like existing Web2 data, especially like off-chain like finance data, personal data from existing like Web2 servers. This is actually a quite open problem because they're kind of two type of data, like signed data or unsigned data. For example, like signed data means that like ID, like email stuff, like ZK email stuff. So you can directly use like ZK to verify everything. But there's a lot of, I think, large part of the data is kind of unsigned, especially like using your website. There is a way that you can verify that data is actually from the intended sources. So that's a problem we're going to solve. And so imagine that if we can solve this problem, we can actually bring tons of new data, tons of like private data, valuable data from Web2, and then you can build things in Web3. So that's the motivation. So how we got to do that is that we found that every single like data you can access off chain is actually you use the TLS standard like HTTPS. So we design a protocol, a cryptographic protocol that enable the users to prove that this data, this encrypted data, is actually from some intended sources like Coinbase, like SSA, so anything, any website, but you can name it. So in this case, we can now enable anyone, especially for the end users, to prove his private data. It's not like Oracle private data, it's actually from intended sources. And then we can connect with zkVM like Brevis. We can further to perform computations on that data. I think it's kind of complete end-to-end solutions for the end users to leverage his like private data to Web3. We are now helping like stablecoin projects to provide proof of reserve using zkTLS plus zkVM. So how can for off-chain data, for off-chain assets, for example, if we have like on-chain data, on-chain assets is very simple. So, but how you can prove that you have enough assets off-chain, like in Coinbase, like in Binance? So we use like zkTLS to first make sure that all the data is actually from the exchanges, and then use zkVM to like process that kind of data, like filter data and aggregation data, and then they can only like publish the total amount of different assets without leaking any positions of their accounts and without leaking any strategies they're doing off-chain. So this kind of like we can provide this kind of like private preserving POR for stablecoin projects, and it can be extended to like RWA or Stockify because you have a lot of things to prove off-chain. So this is some new things we can offer to the community, and we think that there is a big like opportunities we can build on other things. So that's basically the moderation. Yeah.
You mentioned that if it's on chain, it could be checked easily, but it's not true all the time. So if you try to find how many transactions did addresses, it's really hard. So it could take so a lot of time. So it's even worse for on chain also.
Yes. Yeah. We now mostly focus on off-chain there. Yeah. Yes.
The reason we're building with ZK and for ZK is because it's the coolest thing around. It just gives you like 3 extremely interesting properties for any type of applications. And if you look at like the chronology of the application of ZK in blockchain, that's usually how it follows. You started with privacy, like Zcash. If you want to build a privacy preserving application, it is an extremely powerful tool. Anyone done the Aztec sale recently? This guy right there. So the way it worked is in order to prove that you were not from a list of countries that were excluded from the sale, like the UK, which is extremely ironic for the Aztec team. You just use your passport, you tapped it on your phone, and it generated a proof that you were a citizen of a country that was able to participate in the sale. And this is really, really cool because this is privacy preserving. It is very, very efficient because you do not need to contract a third-party service that's going to charge you like, I don't know, $2, $3 per KYC. And 3, it is very, very accessible. On top of privacy and scale, using ZK in your application means that you can have more people participate in it just by using the existing form factors that they have, namely a passport or an ID card. So that's what we're trying to enable with Hyli. Just make it as easy as possible to use these tools in a blockchain application.
Yeah, I agree with all these reasons, and that's why we should have ZK proofs, but someone needs to verify them, right? So that's why we need zkVerify.
Next, we're gonna basically we have an overview of like the different verticals in the ZK space with these projects that are presenting in this panel. But we also want to understand like what's realistic in ZK right now with the technical constraints that we have, and also what can be achieved with what we have in the progress. So maybe starting from zkVerify, can you share a little bit about like what's realistic today with the ZK technology we have right now, and what are some obstacles for production usage or for adoption that you see?
For sure, it's education. What we have and the evangelists of ZK that are starting everywhere, trying to understand ZK and apply them in every possible way. That's standing in the way for sure. Then different standards that we see, like different curve types and different versions that needs to be verified somewhere in the end, right? That's the thing. And also like the basic understanding of that. Usually people need to go through maths to understand that. And I think that's actually standing in a way of adoption. And I think that once we have a user that's not even aware of using zero-knowledge proofs, but it's actually using zero-knowledge proofs in the backend, that's when we're going to see a lot of adoption.
I see. So basically, user experience, how to smoothen that is one of the key bottlenecks yours. Yeah, definitely. Yeah. Makes sense.
Maybe a little bit controversial, but I would say, so obviously you have the usual suspects when it comes to ZK. It's difficult to audit, it's difficult to maintain, etc., etc. It's getting a lot better now. You mentioned zkVMs before, and this has been definitely a force of nature. Rather than hire like 15 cryptographers in your team, you can just use RIS0, Brevis, SP1, all these good zkVMs, and it's just fantastic. You can just use write in Rust, and that's great. But obviously, there's still a good 100x to be found in terms of proving speed, in terms of RAM requirements, and there's been a lot of effort that's been spent on server-side proving, because this has been where most of the funding has gone. You may need to prove Ethereum rollups. But when it comes to client-side proving, for example, there's still so much that can be done. And so shout out to the Ligero team, because they really built something that is quite different from the rest of the team, that is very, very efficient. And they were recently, it's the proof system that is used in the Google Identity solution to prove that you're over 18 and so on. So even the European Union is looking at this. So I definitely think basically we need more infra, we need more tools on top of more education. Yeah.
From our perspective, we found that actually client-side proving system is the most challenging part for us, because we do design like for zkTLS itself, because it has to be run in the client side, because like mobile like extensions. So you have to use like very lightweight ZK proof systems to improve the user experience. Otherwise, people cannot wait like for more than like 2 minutes. It's too long. So we designed that. And for zkTLS, it's very cheap. You can like prove very complicated circuits like in 1 second. But it's not succinct, but it's okay for zkTLS. And when we go to the zkVM part, we have such challenge, because most of zkVM or zkTLS, or like as a techno, they are designing for the server prover, because you can put GPU there, you can put hardware there. It's very fast, but they cannot be like putting the client side like mobile like extensions. It's very, very hard. You cannot even like install the SDKs there. So yeah, we try different things, try different ways to work with these different projects like Brevis. So we kind of now maybe the temporary thing that we can do is using TE and put the prover inside TE is okay for now. But maybe in the future we want everything can be run in the client, because now we have private data. So we don't want to outsource into that kind of private data to the third party, because our clients cannot trust these kind of provers. We now are trying to use like Aztec nowhere. Probably we can run inside the mobile, but no, not in the extensions. If you guys know kind of very efficient client-side proof system can, provide this parts preserving property, then we know I'm gonna like to integrate with these parts. So for now, I think especially in the future, when you want to build like private preserving applications for private data, we actually need this kind of client-side proving systems, very lightweight, to support different client forms for them to have better user experience. I think it's the main challenge we are now facing.
Yeah, that makes sense. And combining what Milica just shared on user experience and what you have mentioned, you basically focused, like what you have shared is focused on like the performance side of client-side proving. And do you foresee maybe a future where like we don't need to have end users to go through like installing different plugins for them to prove like their TLS connection or web usage?
Yes, you can. You can deploy everything in the web using our zkTLS support, because we have like awesome version of zkTLS protocol. It's doable for zkTLS itself, but it's not doable for zkVM part of ZK. If you want to prove more complicated computations on that, it's very, very hard. For now, we do not find, suitable like libraries or SDKs in the community that they can support that, because we want to prove like there's a kind of benchmark. You have to prove ECDSA verification in less than, I think it's 10 seconds. Can you do that? If we cannot do that, we cannot use it. So that's the benchmark we're going to do. If we use TE and the GPU, like the zkVM stuffs, yeah, you can prove it less than in 5 seconds. It's okay for user experience, but you have in the different like trust assumption there. But yeah, it's kind of always trade-off.
Yeah, definitely something to work on.
Yeah.
Vladimir, do you want to share something?
I'm feeling that I'm from another space from these guys, to be honest. So my question to all of them, so what you are proving? So what is the basic scenarios?
A baseline of proof is that we have to use zkTLS to prove that zkTLS attestation is valid, which means you have to prove that this ECTSA signature is valid. So that's the, I think there's a lot of like experience or like a lot of like projects are working on that, but most of them are not, satisfiable in the client side. Like, can you prove it in less than 10 seconds? I don't know, maybe not.
If I could add from application side, so what's the problem for us? So we want to get some data verified and based on this make a decision. And right now, sometimes it costs so much for us to use a ZK to get a ZK proof for, to collect some data about the user to use it to our protocol. So the cost is a problem. And also the problem is that if we need some ZK proof, we should initiate it. It's needed only for us. So I hope that in the future, some data which ZK coprocessor processed and create a proof can be used by several companies, and that's we can share costs. So I would say that for application layer, for the apps from Dexes, it requires to reduce the costs or make more protocols which start using ZK proofs inside for making decisions, because we can share a cost of all of them. So that's the main point for us at the moment.
Yeah, I think that's really some solid first-hand feedback for our ZK projects here, for you to basically figure out the goals for optimization. But I think you do have some technical advances that you want to share on that front, on performance, on cost as well. And we're going to get to that. So our next question is productization side, which is to unpack how teams balance idealism with usability and business needs. So like for ZK projects, we have so many different verticals that we are working on. How do we measure return on investment or value for ZK investment? That can come from projects that have implemented ZK in a way like Algebra, or that can also come from feedback from the partners, the ecosystem you are talking to for our ZK projects here. So maybe let's start from Vladimir.
Yeah, so it's, just to repeat what we discussed. So sometimes we do not have an option to find data on chain and get verified without ZK proof, because it's so much and we could not do it on chain. When a DeFi started, everyone says this, please remove from centralized exchange and let's do everything on chain. But now we understood that not everything could be done on chain, and we try to find a way how to make it on the same trust level that everyone trusts and could check, but without like on-chain activity with the blocks and all the stuff. So that's how our ZK helped us. And we have one feature that it was discussed many times. So we analyze user behavior and also analyze pair volatility, and based on this make a decision what should we do in our pools on the DEX side. And it costs us 5 times less if we use ZK, because otherwise we do everything on chain and it's a lot of data, a lot of execution. And users don't want to pay gas for this one, because when somebody swap, he pays for all this execution. And ZK is not needed, so it's for at least for one feature we have 5 times more savings thanks to ZK. So that's a good example. For others, I would say it's not so obvious.
I gotta say something about digitals. Yeah, I think the first step is that we should provide, different like SDK to support different users to developers, like in different platform like extensions, mobiles, backend, because we don't know what kind of things the developer wants, but we can support everything there. So it's not that hard. And the thing is that we need the developer to use like zkTLS or zkTLS SDKs, or to find what kind of data source they want to prove in a very easy way. That's the goal of our like products. And how to measure the adoption is that we want as many as possible like applications to use zkTLS. That's very, very simple, because every single service, zkTLS service, we can actually charge from the users or developers. And actually that's kind of like, if we can bring like more like applications using our SDKs, then we can bring like more revenue. So Yeah, in terms of this, actually, and not just provide this kind of like zkTLS as a service. We want to make it like a more zkTLS network. So I'm gonna like maybe explain a little bit later about how you can bring more partners in. Like you can share the revenue, and then you can further like bring more applications. Like we can become a win-win solutions for the testers, for the nodes, and for the ecosystem. So it's kind of like new things we're now building. I think it's quite interesting, and it's the first thing that we promote the market, and maybe in the future there's kind of very interesting things happen.
For us, it always comes down to, can you actually make it run? So that was, I mean, we run a really big benchmark on, you mentioned client-side proving in the context of a browser. So we worked with a researcher, and it was like a very specific mission. It is, what is the best proving system in order to prove a SEC-P256 signature on the SEC-P256K1 curve in a browser? And we reviewed absolutely everything. So you were mentioning like idealism and how do you reconcile all of this? We looked at everything, and the mandate was just look at everything and find the best thing. And so we took a very naive approach. zkVMs, we don't have enough RAM to run any of this. We will have for the next 5 years, probably 6. So that's another question. Then you look at what other projects have done. Spartan, Halo 2, you're like, okay, in theory, it seems that it works, but we just cannot run this thing. And then you run into gross CC, it's like, okay, it seems good. And then you realize that the proving key is like gigs. And so you just like go down the stack and you end up, and our recommendation was use more. So you mentioned that you were doing proving on TEs, and that's also what the Sylve people are doing, the Z Identity project. Obviously, we need to get to a point where everything can run in a browser very efficiently, client-side zkVM, etc. In the meantime, we also have to be extremely pragmatic. And even though, of course, everyone has seen the TE.fail announcements, no one wants to use TEs, it makes you look bad, everyone wants to have like the perfect absolute solution. In the meantime, we all have things to run in production. So yeah, our recommendation for client-side proving is to use more. It works really well.
For us, how we do prioritize things and zkVerify is first we ask developers what do developers need, right? Do they need more proof types? They need more proving networks, attestations, some other networks. So that's how we start. And from there on, we start building our priorities to see how it all lays. And we ask our business partners as well to see how can we be more useful to them. And yeah, I think we're more developer-centric than anything.
Yeah, so to follow up with that, like what are some trade-offs that you are making or you decide to make because of the priorities you have spotted in customer needs or end user needs?
First of all, we need to respect our roadmap. So we really made sure that we make an effort to actually follow that we have mainnet launch. So that was our first priority. And from there on, then we had to accommodate other proof types or other station networks, but that was our priorities. That's how we started. That's where we start, right? And I don't think if you lay your priorities well, that you would have a lot of bottlenecks there.
For us, it really like the idealism of how ZK proofs have to work. Everything will be real-time proving, etc., etc. And in effect, it is still very expensive to run. It's still quite slow. So the design of Hyli was taking all of this into account. So we make sure that you can get like instant verification, instant soft confirmation for your transactions, even though your proof can take some minutes to generate. So it's a question of you making sure that you future-proof while at the same time making sure that you are usable right now with the current tools at your disposal.
Yeah, first, I think it's always the security and the user experience. So as digitalists, there is kind of assumption that the client has to prove to another attester that they have the right data. So if that's just one single tester is kind of not secure because it kind of like single failure attack there. So to solve this, we now proposing this kind of like we call the test network. So we bring multiple testers, not just us. We are like sharing revenues with testers. For example, like when this tester is randomly selected by the user, so we like share 80% of the revenue to that tester. So then they can like again like secure our network and then we can like bring more like a picture there. So yeah, there's a little bit like low down or reduce the performance a little bit, but I think it's okay for us, especially when we secure all the money there. So we need this kind of decentralization to to cover these two things together, because it is much more important than like performance right now. Yeah.
For Vladimir, I know you're more on the product side. I mean, for using ZK, but maybe you can share like what are some, you mentioned some, like, but what do you think are some core issues that you would want to see happen, I mean, to be changed with ZK advancements on the product side, like some user experience issues or, yeah.
Okay, so our next step for this ROI exchange, we try to use AI agents, and I just back from an AI agents event, and it's funny that nobody on this event okay to put money on AI agent. So everyone said, no, it's not ready. Please don't use AI for trading. So it's not ready. Not put money there. It could just give you some suggestions. One of the reasons I believe that we don't have a good ZK integration with the agents. What we could not check, it's let's say automatically, or get some proof that it was done what was required to be done, right? So we can say that if you can see like some patterns, then change fees or liquidity add or something like this. So we need to check, and I think that's extremely important that at some moment we could find a way how we could connect AI and ZK in simple way, or that protocols like Algebra could start use this one, because right now AI stopped is the point that we could not be 100% sure that it's doing right, and we need somehow to check it. So we need to find a way, maybe thanks to these guys, to connect ZK proofs with AI agents and do it automatically for us. It will be a huge step forward. So
yeah, I think checking the validity of the models and also checking the data sources are definitely important for like dynamic AI usage. And on that, is like zkTLS ready to provide us with maybe verification for off-chain data for AI uses right now?
We actually have a demo, so we can prove that the picture is actually generated by ChatGPT, and the picture is kind of like 300 kilobytes, and then we can prove it in less than 1 minute in the extension. So it can be much better, much faster. But we already had that demo right now. It's very easy for us to get that demo.
That's definitely a good start. Sylve and Milica, do you guys want to share anything on AI agents, and also if you have any overlap with that front?
No.
Cool.
I'm a B-roll with you, no.
Cool. And we have limited time, so we're going to go straight into collaboration. Here we're presenting projects within different verticals in ZK. There are definitely a lot of ways for projects for verticals to collaborate so that we can advance for similar goals like performance and cost. Maybe can each of the projects here share a little bit about how you visualize collaborations across different ZK tech stacks, and also like is there any concrete examples of how you work with other ZK projects? Maybe we can start from Milica as well.
Sure. So everyone's trying to prove something, and we're the ones to verify it, right? We have multiple proof types that we can verify, and on that account, we can collaborate with multiple companies. And also, everything that our developers are creating, all the projects, it can be verified. You can even verify that the AI agent is actually trained on certain data set. That's really interesting. You can verify TEs as well using ZK, and actually having signed a photo from some event that it's not AI generated can actually make it or break it in some governments even, because it's actually genuine photo and it's not manipulated.
Okay, I think in the future that there's more projects gonna like leverage private off-chain data to build things like, or leverage the benefits of blockchain. So it's kind of a combination of these two things. So that's I think that's the value of zkTLS. And totally need to combine these other like ZK projects. So this is kind of the future. I think there's a lot of like opportunities there. Yeah.
I feel that ZK is so young, to be honest, to be used by applications. So it's every time we try to use it, we work on daily basis for integration, to discuss something and so on. So the way how when ZK become API for something, I think it will take maybe 1 or 2 years. So from now, from application side at least.
Thank you guys for sharing your insights and also your experiences with the ZK building in a